Hello, everyone. I hope you guys can hear me okay. And I hope that we are recording well. And we're going to give a little bit of chance for the rest of the crowd to come in. I want to focus on what we have here today. And let me just get things aligned here a little bit. Hopefully, I'll be able to sneak in too so we can have a good preview. I got plenty of recording power on the external laptop, and I'm also checking and see if there is any of you out there that are going to join us. I'll give you a few minutes. 1, 2, 3 testing. 1, 2, 3 testing. The mic seems to be working fine. I hope we can get enough people here to do our job, but we are live. And with that being live, we have great responsibility. Okay. So I'll give, I don't know, another 2 or 3 minutes for everybody to come on board. Anyone needing to get on board? We're going to have about an hour worth of time here because I've done some preliminary work already. So, all right. Couple of minutes, and then I'm going to record this thing for everybody to see, for the world to see. All right, that's the plan. That is the plan, and I think the plan's going to work out. Okay. All right, it looks like someone has joined us. Could you give us a shot message on the chat box? Where are you watching us from today? And again, we're going to start our conversation and our demo here in just a little bit. Waiting on anyone else that may want to join us as we go forward. And thanks for joining us today. All right. Very good. So thanks for showing up today or for watching this replay. I'm Dr. O, and what I wanted to do at this time, we have about an hour or so, we'll see how well we do, is to give you a live demo here on how to build a system for your own training needs, training capabilities. Okay, so um, that's what the purpose is all about. Let's see if we can accomplish this in the time that I've set for this. Okay, so um, first of all, if you're going to be building this and you don't have a lot of manufacturing hands-on mechanical experience, I said make sure you wear safety glasses as you do drilling and cutting. That's an important recommendation. And in addition to that, if you have a vise that will help you sustain the parts that you're going to be drilling, I will say that's probably a good idea because it can get a little bit messy here. Okay, as we do things. So anyhow, with that being said, what I'd like to do with you guys today is replicate um, a trainer system that I have developed, and this is almost like version 3 or 4. I don't know. I've built multiple boxes where PLC controllers are used, and um, not only that, but I have learned a little bit about the issues that come when you're designing a box like this. So one of the problems I had on the previous version was that the space was a little bit tight. And so anyhow, this is the last or latest version of the controller that I built. There's 2 versions before this. You may have seen a little bit different controller if you have taken some of my PLC classes. Um, but this is the one. Let me plug it in real good here. There we go. And so this is the one. We're going to try to replicate this in a larger box. That's the purpose. So here we got the power switch on this one. So that's power switch. Then we got the stop switch right here. We got the start switch in here, right? When stop is hit, you have the pilot light indicator that system stop. When the start is hit, you have the indicator the light is on. You also have what I call a jogging capability on this one here. That's that's another feature that isn't a trainer. And then we have what I call a master control reset, which is this switch right here. When this master control reset is reset, there's nothing else you can do, right? Nothing else you can do but just the master control reset on, right? So again, master controls everything here and nothing happens. But when this is off, you could do various things with this, okay? And so this controller is already programmed. It's got a well, not a built-in. All of the controllers might have something inside, a demo program or something, but this one I already programmed with the correct operating system. Okay, so this is what we're gonna be building, or something similar to this. Okay, this is what the project's about. So I'm gonna get this out of the way here. So we can get a little space. Okay, so we got that one out of the way. And we're going to explain here a little bit what we're working on. Okay. I will also make some of this information available for you guys, available for you to be able to download whatever you need so that you can replicate or build your own system. That's something we're going to be doing here also in this program. I will be uplinking your materials so that you can use that later for whatever purpose you want to use that for. Okay, so that is the plan. That is the plan that we have. And I'm actually monitoring myself here on my device to make sure that the signal is going out strong, okay? So let me mute myself on the device here. All right, and we're gonna set it up here. Very good. So let's go and start with information. Okay. So this is where we're pretending to build. Okay. This is going to be our box, PLC in a box, do it yourself layout. And if you can see this on our layout, we have the box. We also have the power supply. Okay. And we also have the input part right here. We also have the output elements, pilot lights. We have the processor in between. A few other things that we have is the RS-232 programming cable. And let's see what else we got. I think that's it. So this is our layout for you to have an idea of what is going to be constructed. And of course, I already show you the actual box, and there's going to be more that we're going to be showing you here as we go forward. Okay. The other information that you may want to know is that I'll make available for you guys the possibility to order a kit from my site. Buying a PLC trainer like this is not cheap. The processors or the PLCs are pretty expensive, but I find a way to put together a kit for you guys under $200. So I'm going to be offering you a kit with all these parts for $199. That includes shipping and handling in the US. If you want to build your own thing and you don't want to go through the trouble of trying to find out pieces here and there, trying to piece out what you're building. And so anyhow, let's look at the agenda here. And I have done a lot of pre-recording just because it takes maybe 3 hours, and sometimes it might take you more to build this, especially if you have not done any mechanical or fabrication work before. If you're a fabricator, if you know electrical mechanical work, this might take less than that. But anyhow, here's the agenda. I'm gonna say this is our agenda. So let's write down agenda for today. Okay, and our agenda for today is looking at the tools, parts, and materials that are needed for this. All right. Then we're going to do some measurement, cutting, and drilling, solder, assemble, connect, and then power up the system. Again, I've done a lot of preliminary work because I want to include that preliminary work in my course online, where you'll have access to both all the details, but also as you subscribe and order, you will have the whole kit. So that's our agenda right there, okay, that we want to go by. All right. And again, I want to show you here, this is an older version of the system we're building today. Okay, this is already a working system, right? And this gives you the capability to do a lot of testing of projects and prototypes that you can later on utilize for the purpose of developing a solution that involve controllers and I/O sensors and things like that. All right, so with that, let's look into the tools, parts, materials. The essential tools you need here, you need a power drill. You need drill bits, right? You're going to be drilling holes. So these are tools. You need the tape measure if you want. You can also use engineering paper, such as I did here, to do kind of an eyeballing location of where the components are going to be. I'm going to show you here in a little bit what I did with this. This is the simplest way I found to mark where I need to drill and cut. All right. You also need, screwdrivers, wire splicers, strippers, long nose pliers. Of course, you're going to need solder and a solder gun, right? Sometimes you could use a crimping tool to crimp terminals, depending upon the kind of devices that you have. So I'm going to show you here that mix. And so you need those materials. You need those tools. And then as far as materials, you're going to need wire. If you buy the kit from me, I'm going to make sure that you have a roll of wire, just like the one that I have here. So you can take that with you. Okay, you can have that with you, roll of wire. Okay, so what else? So those are materials that you're going to need, and tools. And of course, the essential parts for the building of the project are going to include the box, right? You need a solid box where you can build that. You need the controller, right? A PLC controller. This is really the cheapest controller I can find in the market for under $100. And then, of course, you're going to need your IOs, your inputs and your outputs, right? In this case, I'm using push buttons for inputs, and I'm using pilot lights for outputs, right? You also are going to need a form of a power supply. These devices and controllers work with 24 VDC. Therefore, you either are going to need a DC source, right? Like this one, this DC source takes 100 to 240 and outputs 24 at an amperage of approximately 0 to 3 amps. So this is the one I plan on using for this. Alternatively, you can actually have a transformer type power supply, right? This is another type that will take AC and will provide you DC at the output. This is the other option for this, okay? And maybe for simplicity, this is what I recommend it. That way you don't have to mess up with anything there, right? So I'm gonna use either one of these two guys. to power up our controller. All right, so that's an explanation as to the tools, parts, and materials. Next is your measure, cutting, and drilling. And so I have here the controller disassembled for practical purposes. What I did is a squared engineering paper, right? I bend it in half. You can see that. And then I place it on top, right? And again, you're going to have this video because I already recorded. And then I place the components. I'm sorry, I tape it to the cover, to the box, and then I mark where I was going to put the input, the output, and the controller. All right, and with this and here, I went ahead and drill and mark where the holes are going to go. Okay, so we are in the measure, cut, drill part. All right, and so what I'm about to do now. Now this can be a little bit dangerous, so I hope that that you know how to handle electric power tools. Otherwise, you could end up with a little bit of twist arm. So full disclaimer here: as you're doing this on your own, you have to take all the safety precautions that you need to take, right, to do this. All right. So since I already got everything marked, okay, next thing I'm going to do is I'm going to show you how I drill the holes. Sorry. Okay, I'm going to show you how I drill the holes. And then we're going to do some installation of components. And then we're going to do some soldering if we need to. So I am going to, so you need for the inputs, there's a couple of inputs here I want to put on. And so these are the inputs. All right, one of these guys is a push button. The other one is, it's also a push button. Okay. And if you're in doubt, you can always test these devices, right? It looks like I lost a little screw here. So that's going to be a problem. I just realized that I lost that little screw. So, okay, here I go. So I have another one here. So I'm going to use this make and break switch for power. So I'm going to use that on top right here. And then I'm going to use this blue for another push button. Okay. So let's go ahead and start by the easy part. This hole is already made. Okay. So I am going to go ahead and put this push button here. Let me move the camera a little bit so you guys can see. That's probably better, right? You can see both sides. Sorry about that. Okay, so this one is gonna go here, and I'll show you how I drilled this, okay, in just a little bit. So they're a little bit tight. And if you feel like you need to re-drill this, you can always do that. But be cautious. You can hurt yourself when you're doing this. And so I'm going to do a little bit of a reaming here. And it's a good thing that this is plastic. I think ideally this material should be machined. But anyhow, I don't have a CNC machine. There you go. So that's what I wanted. That's in. And then on the back, I'm going to put the nut and the washer and the nut. And I want the position of the terminals to be vertically aligned, just like that, right? Because I need to do some wire connecting and soldering here on the sides. Okay, so how are you watching over there, my friend? Send me a message on the chat box saying I'm watching okay, I can listen all right. And many others are going to come later, of course, to replay this. Okay, there you go. So that's how I place that component. Now I am going to go ahead and drill. I'm going to drill. I'm going to place this box in, or this cover in the box, because this can shake you a little bit. So I am going to drill a couple of holes, right? This hole and this hole, and this one is going to be for the power. This one's going to be for another indicator that we want to place on. And so I got a few things in here which I should be able to get out. Make sure I'm safe. I got more tools than I need to have here. But anyhow, let me just get them out. I got a bunch of parts in here. Some of these parts I'm not going to be needed. So let me get this out. Okay. And let me make a little room here. Okay, so I am about to drill a hole, actually two holes, but one first and then the other, to show you how we do the electrical parts. Again, we've done the measurement, we've done the tracing. We are going to go ahead and drill. And so the first one hole is 1/2 inch. The other one is 3/4 inch. And again, be safe as you do this, because it can get a little bit messy. Okay, so especially if you've not done mechanical work. Okay, so we're going to drill this first hole right here. That's going to be for my power switch. I already got it marked. I'm going to rim it a little bit just because I know that the hole needs to be a little bit larger. The 1/2 inch, I think I got it. I'm going to sample. Ooh, maybe that's a little bit loose, but hopefully we'll be able to sustain it in there. So this is going to be the power button. Usually I use a toggle switch of some sort, but anyhow, we're going to use this, which is what we have. I may need a washer for this. All right, I went a little bit too far. It will stay, but let me just look for a washer. Give me a moment. Again, so the idea with this is that you want to measure properly. So I couldn't find a washer, but it's all right. It's gonna be okay. So I'm gonna place that here. It's gonna be all right. So let's put this one. Okay. So this is going to be our power button to power up the whole system. And then we'll figure out what we need to do the wire connections. Okay, we're not there yet. So this is going to be my power switch. Oops. It's a little bit loose. So this is the kind of problem you can have. I actually went a little bit too far with the drill bit. So I am going to do a little bit of doctoring up here for these. And this is what I'm going to do. Okay, this is okay. So I'm going to create a little washer in here. I should be careful. I don't have washers handy here. So I'm going to do a washer out of a piece of solid cable. Okay, because I don't have a washer handy here. And this is going to save my situation so that this stays really good in here. So there we go. It's not a site a NASA project like they say, right? It's only a PLC trainer. And so that's that. Okay, I may have to do the same for this side. Okay, so there we have our power button. That I have to doctor up a little bit just because I went a little bit too far reaming the hole, and so I have to do a little bit of doctoring up this thing here, and that's okay. It's going to be all right. So this is going to be our power button, right? Make and break. Okay, that's as tight as you can get it. Okay. I will have to replace that by a nice washer later on, okay? I can do that. I'm sure I have a washer available. We're gonna leave it there for now. Okay, although I can improve this a little bit. Very good. Okay, putting on the power button. Okay, so that's our power button. Okay, so we created a little washer for that purpose. And we got that too. Very nice. So next, I'm going to drill a couple of holes for the other side. Okay, so 2 holes in here. And I'm going to just turn it around for convenience, okay? We're drilling 2 larger holes. And that's for these 2 lights. These 2 guys in here. And once we do that, then we'll be good to go. Okay, let's do the larger hole. So for that, I'm gonna switch the drill, the bit, to a larger bit, and we got this hole to place the component. That's ready, and then a new hole I'm gonna drill in here. Again, be careful as you do this. There we go. So we got that hole drilled. And you're gonna have to doctor up a little bit because of you see that? It doesn't go in, so you have to enlarge the hole a little bit. And how you do that is you go around easy. Kind of enlarging that hole a little bit. So that's the holes. All right. I'm just checking my own channel. Make sure this is still going strong. Okay. And it is. So, all right, we got the hole drill. Cool. And of course, we got some dirt here. Lots of little parts inside the box. I'm gonna have to get these parts out. To clean this up and to get this ready for production. Okay, so I'm gonna put this part in here. And we got some dirt here. So there's some dirt inside the box. So I'm gonna clean that up a little bit. And with that clean up, I'm gonna go ahead and start installing the remainder components that we have installed. So, all right, there we go. That sounds pretty good. So I am going to start with this one. So you unthread that. There's a little washer in here. You can leave it anywhere you want. So we're going to place that in here. And it should go pretty nice like that, right? So nice. And then I go back and thread this knot in the back. Oh boy, 41 minutes into the work. Okay, so that's that. I'm going to do the same with the red pilot light. Unthread. And hopefully it's going to go in really well too. Put it on. Thread in. And that thread in real nice. Make sure those holes align vertically on both sides. That's how you want it. And I'll explain why we want that. Okay. So, like so. Okay, so we're putting on the outputs or pivot lights. These are the guys. So we already got our platform ready here. We got the base for the controller. We got the input, start, stop, power, stop, start, and a couple more push buttons for jogging or whatever functions you want. And then we got our output indicators. Okay, pilot lights. And I guess we have done the parts, materials, tools, measure, cutting, drilling, solder, connect, and assembles what's remaining. Also, this box needs a hole on the side so that we can put in the power cable, right? That we're going to put in as we go forward. Let's see. So let's look at the back of this front panel to see what is the work that we need to do here. And if you can see, I already started some work which I pre-recorded for you, and that is wiring the inputs and part of the outputs. I'm not done yet, but I want to show you here why is that I'm wiring that up. I'm going to give you the, so there is a electric schematic I've developed, and on this electric schematic, we have the inverter AC to DC. We come from power 100 to 240, and then we transform that and convert that to 224. And then we go into the controllers rails or terminals, and this controller, it's a little bit different than the one I have here, but the essence is the same. So this controller has on the left hand side are the inputs, on the right side are the outputs. Now this is also input, which is not on this schematic. These are actually analog inputs. We're not going to use them here for purposes. That'll be for a future enhancement of the trainer. For now, we're just going to use the input, discrete inputs, discrete relay outputs, right? And so what I've done here is I already have done this internal work. So we're going to continue that internal electrical wiring work. And so notice that from the common, which is the, let's see, the third terminal right here, this is the common. You hardly can see it. But right there, the third terminal says common. From the common, we are going to power up or provide power for all the input. These are the push buttons, right? And then we're going to connect the input to the corresponding terminal on the input module, which is this wire right here, right? But let's finish this part of getting this wire ready so we can connect this. And then we're going to get this wire ready so we can connect the outputs likewise. So let's put this on the side for a moment. And notice here, these are the inputs, right? These are the inputs. I already got some of these wires. First of all, these loop wires that connect the sides of the terminals represent um, sorry, represent this wire right here. I need to connect all of the input side of the input push buttons to one common positive, right? And this is what we are here. So um, power is going to come through this one here and through the common, right? And so we're going to have to do something here to make this happen. So let's go ahead and figure out how we're going to be doing this, okay? So I am going to finish up powering the last element here. And how I do that is I'm going to connect this wire to the terminal of the one down below here. Again, what I'm doing is I'm connecting all these wires here, right? All these wires. And those wires need to be connected to the common of the controller. We'll see how that's done, okay? But I wanna make sure that I have all these wires. I need all these wires being connected in common, and I need all these wires being connected at some point to the terminal of the controller. We're gonna see how that's done, right? But we're prepping both sides, the inputs and the outputs at this moment. Okay, so I need to hook up my soldering gun. And again, be careful if you're not done in solder. Don't burn your fingers. Okay, so here's my soldering tool. I'm gonna be hooking up here in a minute so we can start doing some soldering. You can terminate some of those wires when you can with spade or eyelet terminals, but I prefer to solder. It's a more elegant solution for this. So I'm going to solder this, and I also will need to solder for this, just like I have for the other ones, the cables that eventually are going to go into the terminals of the input side of the controller, right? So this is all common, right? And then this is going to be the individual inputs that are going to go into the controller. So my soldering gun is heating up, and while that happens, I believe I need another couple of wires. I'm gonna cut a couple of wires here. I've been cutting them around 7 inches, and that's pretty much what I need. 7 inches, more or less. Enough room for what we need to do here. And then you want to strip those wires, and when you strip the insulation out, you also want to, let me do this a little bit. Here we go. You also want to tin these wires. So strip and tin, because usually with stranded wire, what happens if you don't tin the ends, the wire tends to be all spread out, and so hard to make contact. So tinning these wires is always a good practice. So I'm prepping some more wires, and I'm gonna tin them here in a little bit before I solder this wire. So I'm doing some prepping, and I already did some of this for the other wires that you see there, right? They're already, let's see, is this heating up? I think it's heating up. So I'm gonna do some tinning. Yeah, my ventilator is running here. I'm gonna stop that ventilator. because it's robbing my heat. Okay, so less noise. Okay, so there we go. I'm gonna tune this. I think my soldering gun still heating up. So there's a lot of prepping, like what I'm doing, that it goes into this guy. So I've done some of these. I spent about 2 hours, I think, prepping a lot of this. If I have to do all of these individual wire prepping, it'll take us more than what I have a schedule for this morning. So I'm just giving you a short demo here live of what I did for the other cables, right? I'm prepping the cables. Okay, there we go. Why do we tin this end of wires? Well, because if you don't do that, when you connect these wires to the terminal, sometimes the connection is not so great. So you want to tin these wires. It's a good way to prep the wires so that you can either solder or connect to the terminals. Anyhow, there's that. I said that we're doing this part right here. We're connecting all these wires, common wires to the, so this is power really going into the sensors or input push button, right? So we're gonna wire all of this, and I'm gonna be doing the last one here. I'm going to tin this here, terminal, so that when I solder, I also don't have any issue with the solder sticking to the wire. There we go. And that was the last one, right? That was the last one. However, I need to also connect a wire out of that push button. And this seems to be a little bit long, so I'm going to trim this a little bit. And again, I'm going to put some solder on the terminal. And when you do that, you're just prepping the wire or the terminal so that it takes the wire easily. Sometimes if we don't do that, we might not have the same results. There we go. You hold it there for about 30 seconds to 1 minute, and then you're good, right? So I got all 4 terminals, right? Which are this terminal right here, 1, 2, 3, 4 of my input. And I also got these loops in here, 1, 2, 3, 4 loops, 1, 2, 3, 4 loops on the input side, right? So we're gonna see that in a little bit how that's gonna go. So this is already prepped. The input cables are already prepped. I also got a couple more outputs to prep. And likewise, for the outputs, I need to loop, right? I need to loop the ground side of those outputs, right? So I'm going to have to loop that, right? I'm going to have to loop that. And so that is what we're going to be doing here. We're going to be looping this side. And this schematic shows 2, 4, 5 outputs, but I was able to get only 4 outputs. So I'm going to do this side, and then I'm going to have to wire the other terminal of the outputs to the terminals of the controller itself. We're going to be doing that in a little bit. But in the meantime, I think soldering, okay, so we need to also solder a cable here to the power button. Okay, I'm gonna just prep that before I turn off my soldering gun, because I know that the power switch is what's going to provide power to the whole controller. If this switch is not on, we're not going to have power into the controller. So I am going to just do that. I'm going to cut a couple little wires in here. And we may have to solder this, I don't know, or we could use wire nuts to connect them. But I want to prep these switches here, the power switch, to either connect it directly or, like I said, wire knot it, what have you, whatever we need. So I am going to attempt to solder this directly without any tinning and see how well I do here. So again, these are the power wires that we'll need at some point here for the purposes of bringing power to the controller. Okay, and you can see that the job is a little harder to do when you didn't do the tinning prep part. But I'll get it. There we go. That's one. I may have to add a little more solder. Make sure it's fully soldered. And then we're going to have the next one. I'm going to have to probably prep this a little bit because you already saw that tinning really helps big time. Okay. Pre-tinning, tinning, and that's true for both. So, oops, this one is coming out. So, okay, so let's again, these two little cables are the power cables. This first switch, it's our power switch right here. This is our power switch. Okay, so that power switch is going to be what will bring power to the controller. Let me do a little bit of a tweaking here on my channel. Okay, that looks better. So I am going to add the other cable to the other side of the power switch. Again, one thing I realized is that I could use a lighter size cable. This is 16, I believe. And we could have gone 18 or 20. This stranded cable is a little bit heavy, but it's safe. So it just takes a little more heat to do the job. As you can see here, I'm having to add more heat than what I want or need to. Okay, so you just have to be patient with yourself. I think I got it. I'm going to add a little more solder here on top just to be safe. So again, this is going to be my power cables that will bring power to the board. I'm going to pre-tin this here. Pre-tin. I found that pre-tinning the wires actually help us do a better job. Okay, so that's power. Let's finish up the output. And again, what we're doing here is notice that we need to do a common ground to all the outputs, and then the individual output terminals to the output terminals of the controller. So here I already have part of that loop. I already got the cables ready. So this is going to be an easy piece. I don't think we need the soldering gun anymore. So I'm going to go ahead and disconnect. I may, but I'm going to disconnect it for now just to be safe. Don't want to burn my belly here. Okay, so I got the solder gun disconnected. And I am going to finish up the output wires, right? I'm going to loop this right here. Just like these guys are looped. And then I'm going to bring in the other side of the terminals to connect them to the controller. So quite a job. Now, another thing about this is that you can remove this. Oops, sorry. That was 1 hour, fellas, that we've been live. And I'm going to go with the next hour. I have a scheduled 2 hours for you guys to watch me do this today. So I think we'll be good. Okay, I'm going to remove the cover from this. That makes it a little convenient to lose the screws and to tighten the screws back with the wire in place. Okay, so we're just doing exactly that. Okay, loosening this screws, and we're gonna put in the wires. Again, we're looping here because that's what the schematic says that we need to do. This is the common negative or ground, if you will. And there we go. So again, this is the loop for common ground. One of these guys is going to need to have an output wire so we can connect that. Okay, so we're gonna have to have 2 wires in here because this is this wire right here, right? This is the long one. So I don't know that my back camera is doing such a great job or not, but here we are. I'm gonna loose that up. And of course, you can always ask questions if there's anything that is not clear when you're building your own. I can always try to respond. I watch my messages on my YouTube channel. Okay, so this is a little bit tight here. We'll need a high resolution camera to be able to see what we're doing, but this is what I'm doing right here. Okay. And this loose cable is this cable right here, right? This is the one that's going to connect to the negative incoming line from the power, right? DC power. Okay, so we got that. I got 2 more to connect here. And I will have to cut those 2 wires. Oh, here's one. Unless I lost 1 wire. I might have lost one. A couple more wires are needed. So one for here. Again, these are the wires connecting the controller's output terminals to the actual output load, if you will. We are gonna see how this thing works in just a little while. Okay, so that's that terminal. Okay, this is gonna go in here. We're gonna see why is that goes in, and we have 1 more wire needed. Oops, I lost the cover. One of these guys, which we need. Okay, I'm removing insulation. I'm gonna have to go with this like that because I already disconnected my soldering gun. Okay, hopefully it's gonna be okay. Okay, so I am connecting these wires right here, right? These wires, the wires that are gonna connect to the terminals of the controller, right? Output controller to output wire terminals. Okay, very nice. So we got that taken care of. That was a little bit short. Hopefully it's gonna work. Okay, so here we go. We got our input wires, and we got our output wires, and we got our power wires in here. Now let's follow here what is happening and what we need to do in order to make this happen. Let's work out the internal part of our job. Okay. So if I turn this around, okay, here we got 4 cables which correspond to the four output terminals, and here we got 4 which correspond to the 4 IOs, not including the power switch, right? So look, we're good. So what we're gonna do here is the controller is gonna come on top, right? That's the controller. And based on that, let's start one thing at a time. Let's connect the input signal into the input side of the controller. Okay, so I'm going to use, if you can see here, I'm going to use here. Oh, you know what? Let me do this. So let's put this cover before we forget them. Okay, let's put the cover for these little things. Those are the covers for this. Let's put them on. There we go. Before we forget those. That covers that. That covers that. So. Okay, there you go. So that's the covers. We need to do that. These guys have no covers. Okay, so let's go back to the other side. And input, output, and these are analog inputs. We're not going to mess up with those at this time. And we're going to do the internal circuitry at this moment. Okay, and by internal circuitry, what I mean is we're going to connect all the inputs to the input terminals of the input side of the controller, and all the outputs to the output terminals of the controller, right? This is what we're doing right here. And so let's go ahead and look at this wire right here. Okay, this is going to have to go to the common side of the input side of the controller. So I have it here, and it looks like I have to do a little bit of wire moving here. So let me squeeze these cables over. Okay, and what we're doing again is we're looking for a way to do the internal circuitry connection. Okay. And we're getting there. So I'm just moving cables around to get again the input sensors or input elements to the input part of the controller's input, if you will. Okay. And so what I'm now going to do is I am going to connect the common of all the inputs to the common of the controller's input. Oops, a wire came off, or a knot came off. Yeah, this is the knot that holds the holds the controller's base. So I'm gonna re-thread this here. All right, lots of little pieces that go with this. You guys, again, if you decide to order the kit, I'm going to provide full instructions for you, along with all of the pre-videos that I had to record to get to where I am now. So I'm tightening the base of the controller. I don't know how good you can see, but this is the base of the controller being tied in. In the past, you may have seen my other training models. I have machined a square hole on the cover of plate, and I put the controller inside the box. But this time we decided to go on top. The reason being, this controller has a nice cover. This cover is going to go here. And so when this is said and done, we're going to have a nice situation here with the controller's cover. Okay, where is the cover? Okay, here we go. There we go. It's going to go like that. So it looks pretty nice, right? So that's going to be the end of the work. Let's continue on our work. So what we were doing is connecting this, right? We're doing this. We're connecting these items to the controller's input module. But before we do that, I have to bring all this common positive to the common of the controller itself, okay? So I know this is my common wire right here. I already know that, so I'm gonna bring it through here. We're not putting power to the controller yet, right? That's gonna be the last part we're gonna be working on. And so, okay, this first wire, it's actually this wire right here. This wire, the wire that brings power to the whole set of input, right? So this wire right here is this wire. Okay, I'm going to connect it to the third terminal here, which is the exact terminal for common. This is where the common is going to go. So I'm going to put it in. You may not see because our camera is not high resolution, but this is the common wire that goes into the third terminal, okay? So the wire I just placed right here is this wire that goes into that terminal, right? So the controller has terminal 1, 2, and 3, and that will be 1, 2, and 3, okay? So that is the third one. Next, you could really randomly connect the remainder wires to the controller input, but if you want to be organized, then you have to do it right. And so, okay, we got our common connected to the common, and then what you're going to do is the remainder wires, you can move them around however you want, honestly, because as you know, in controllers, what determines what enables what is really the program, right? That's a beautiful advantage of controllers, that you can wire your wires anywhere you want, and it's your program that decides what signal is taken to do what. So anyhow, you can do it however you want, okay? And I'm gonna have to turn things around. I'm gonna just randomly connect this wire here to some random terminals, right? Again, the work we're doing is we have done this work right here in the top part. Now this wire represents this wire right here, and we need to find a spot to connect these wires. If we go by the schematic, right? If we go by the schematic, and you might want to do it this way, what we need to do is that in terminal input X1, you're going to bring the stop wire, right? In terminal input X3, you're gonna bring the start wire. In terminal input X5, you're gonna bring the next one, and then X7 the next one. So however you want to do that, let's kind of follow what I have in the schematic. So if I follow the schematic, all right, I'm gonna look for X of 1. And so F sub 1 is, let's see, terminal of 5. So terminal of 5, my controller here is 1, 2, 3, 4, 5. That's going to be X sub 1 right there. Okay. So I'm going to remove this wires just to redo this. Okay. And the red wire, okay. You know, this thing is going to keep on popping out. I should put the cover. The thing with the cover is a little hard to see what we need to see, but anyhow, this is going to be popping out on us. So let's go ahead and put the cover for a moment, at least temporary, because otherwise, if we don't have the cover, our controller is going to be popping out because it doesn't have the screws. So I'm going to put a couple of screws for the cover. Okay, I'm just screwing the controller to the board so that we don't have the issue of, right, this coming out. Okay, there you go. So that's fixed. Anyhow, inputs, outputs, analog inputs. We're not going to mess up with analog inputs. We already got the common positive, right, which is this wire right here, right? And we got all of these wires loop here also on the back of these guys, right? This wire right here. So what we need to do is find place for the remainder wires. Okay, let's do it. So for the stop input, okay, so stop input is my second right here. I am going to use input terminal X1, and input terminal X1 is terminal 5 in here. When you get the controller, you're going to see the tiny little letters. Maybe you can see them right there. It's a little bit tall. Right there, there are letters printed, almost hidden, that tells you the terminal labels. So the first one is DC plus, DC minus. Third one is common. And then X of 0, X of 1 is what I'm going to connect this one. So that's terminal number 5. So I'm going to lose that. Terminal number 5. And that's where I'm going to place my stop button. Oops, my AC is going on. That's going to make a little bit of noise. Okay, terminal 5. Okay, so I'm on terminal 5 for my stop button. Okay, I'm going to wire that up right there. Terminal 5. Okay, so we got common. Okay, we still don't have power to the controller yet. And we got X of 1, according to the schematic, right? Which is terminal 5 here in the controller. All right, the next one is the start. So let's start. So the start button wire, I'm gonna go next on the next hole here. Okay, and I'm going to just keep one terminal, and instead of going X sub 2, according to the schematic, I'm gonna go X sub 3. Okay, so I'm gonna lose not the next one, but the one after the next one. So I'm losing this up, and then I will be able to connect the start. Okay, so this cable represents my start button, which is the green button. Okay. You see that how things are taking place? So these are the terminals: common, X of 1, X of 3. X of 1 is the stop input. X of 3, not 2, 3 is the start. And then the next one is going to be this yellow button, which is just another push button. Okay, so let me find that cable. I'm going to bring it through the hole here. And I'm going to use the next terminal, not X of 4, but X of 5, according to my schematic, right? I'm just keeping one input terminal, right? X of 1, X of 3, I'm going to go X of 5, and then finally X of 7, right? So the next one is X of 5, because we got 8 inputs on this controller, 0 through 7, right? And I'm about to connect. This is a little bit rough. I'm gonna trim this a little bit. There we go. And I'm gonna connect here X of 5. Okay, X of 5 is input 4 for us, right? Because I'm sorry, input 3, not input 4, input 3. Okay, so here we go. Okay, we got those. This wire looks a little bit weird, so I'm gonna improve that wire. It doesn't look too good for me. So that's actually input 1. It's a little bit twisted. I'm gonna trim it out a little bit. Make sure it does a better connection. All right, we're just doctoring this up a little bit. Thank you guys for watching online. Who do we have online? Send me a little greeting in the chat. I cannot see your name, guys. Send me a little greeting. Tell me that your signal is being received, streamlined really well. Okay, that would encourage me to do this again, right, for you guys. I invited thousands of you, and just 2 of you showed up. That's okay. Okay, and we got one more. That's the last one, the blue button. So I am going to find a way for this one to go through. And this is the one I did not do a good job at tinning, but hopefully we'll get it to work. Okay. So this is push button 4, which is input 4. Remember, this is power button. It's not an input. This is gonna power up the controller. All right, so I'm gonna go to X sub 7 is my goal, which is the less input terminal, okay? This is what we're doing, the less input terminal. All right, and hopefully we will power this up as we get it completed or close to completed. I have 2 hours scheduled for this. So we're going 125. There we go. So we got all of our common and 4 inputs wire. That's beautiful. Power is going to be the last thing for this controller. And power is going to be terminals 1 and 2, where power is going to come in, right? Terminal 1 is positive power. Terminal 2 is negative power. So we still need to work that out at some point here. And you know what? I think we can probably use, let's see, do we have plenty of space here? I'm gonna have to use the same hole here for, I'm gonna have to doctor this up a little bit. This cable that I'm bringing in here is going to be the cable for power. I already have 2 cables, but 1 cable which is going to bring power in, and then through the power switch, and then out of the power switch into the controller. And so I am going to share these 2 holes for power. So I'm going to do this right now. Okay, I hope you follow me what I'm doing here. I'm gonna put the power terminal into the controller itself, controller power terminal. Not that I'll put power into the system yet, but at some point that's gonna happen. So this is a little bit of a tight situation here. Bear with me. I'm just taking advantage of where we are so that I can save ourselves a little time here. Let me trim that. And so as I did that, terminal 1 on the input side of the controller is positive power. Okay, so I'm gonna put that positive power cable here so that we don't have to worry about that. Now, we're not putting power yet. This is just the cable that will enable power into the system. The ultimate power is gonna be when we connect the DC power supply to the input power switch. Okay, but we're gonna be ahead a little bit here. Okay, so that's that. The only remaining cable for power to the whole input of the controller will be the negative power, right? And that's gonna come directly through. You normally do not switch the negative side of the power supply. What you switch off and on is your positive, right? So again, this first cable is the power cable that comes through the power switch, right? This power switch will have power coming in from the DC AC to DC converter, right? And this is what we got right here. So anyhow, we just got power into the first rail, and then we'll have to bring in the ground or negative cable directly from the source to this terminal at some point when we do the incoming power for the whole thing. Okay, so we got this, guys. All of this being worked out, right? We got all of this wiring. We got all of this wiring. We even got this wire right here. This is the one that we just finished, right? Ooh, and look, I have to do a bridge here. Okay, so it looks like I have to do a bridge. Couple of bridges here. I'm gonna bring negative to the other side of the controller and positive to the other side of the controller. If we don't do that, according to the schematic of this controller, we're not gonna be able to power up any outputs, right? So these two wires, which are internal wires, are gonna have to be put in place right here, right? The negative to the negative side and the positive to the positive side. So both inputs and outputs rails of this controller needs to have power available. Okay, that's really what it is. So this is the design. I already got another system like this, and I battle a little bit because it's kind of weird how this is wired. However, that's how it's wired. Let me sip my coffee. All right, I see Marcos from Brazil. Hey, Marcos, thank you for getting here with us. Who else we got online? You guys are streaming from my garage today. I see a little love greeting there. I know Marcos, I should say hi. Marco Antonio Silva, thank you for being there. And a couple more of you, I'd like to hear from you guys. I'm taking just a little break. We're at the 1.5 hour. and I already had a lot of pre-work done, and I'm finding that hopefully we'll get it done by the 2 hours. We'll see if we can get it done. Let me just sip my coffee, and we shall continue on. This is a fun project that I invite you guys to build it on your own, or you can order the kit from me. And with the kits, I'll give you all the instructions. I also will give you all the videos that we have produced for this. Okay. And this is like project number 5 or 6 for me of this kind, but there's always something new. All right, let's work the other side. Before we do this bridging here, let's work the other side. We already got the loop side, which is this side, right, of the controller. Oops, sorry. We already got, let me see. We already got this here, right? Now we need to connect this wire and the rest of the wires that connect from the output of the controller to the output wires of the output, in this case, pilot lights. Okay, we're going to do that. So it means that this wire here, which is this one right here, right, it's going to have to go to the negative of the output of the controller. So we're going to have to find a way here. All right, so the output of the controller is right here. This is the output. And I'm trying to read what we got there. And the negative is going to go to the negative incoming line, and each one of the individual wires of the output is going to go to the corresponding terminal. So let's see if we can do this accordingly. So I think this is properly wired. Yeah, so all of this is properly wired. So we're gonna use, let's see, we got 6 outputs in this case. We're just gonna use 4 of this output, right? Because that's all we have. And we're gonna leave 2 of those outputs free. So if we do this correctly, I'm gonna take, let's see, if we do this right, so this is the first input, therefore this should be the first output, right? Logically. And so let me get these wires out so we can do this straightforward. So this is the first input, correct? This is the first input, and therefore that should be the first output. If we think logically, this is the second input, and that should be the second output. This is the third input, and that should be the third output. This is the fourth input, and that should be the fourth output, right? So if we do this right, that means that the red pilot light output is going to be our very first output, which means we're going to connect that to terminal Y0. This thing is labeled as Y. If you see the schematic, Y0 through Y5 are the 6 outputs. You see that? And so we're going to use Y0 for the first output. I'm going to lose that up. It's not the first terminal, it's the second terminal. That's Y0. I'm going to actually lose all of them up. All the 4 outputs we're going to use here. Okay. So I'm losing all 4 outputs that I use for my trainer. Okay. And now I'm going to connect the first output to the first output terminal, right? That's what we want. Y0, if you will. Okay. Y is the designation that Mitsubishi uses for outputs. So if I can do this, and you know, I did fail because I didn't tin these wires for the outputs, but hopefully we'll get this done. Okay, so let me see. There we go. So that's output Y0. Okay, Y0 is connecting pilot light red, which is the first pilot light. Very nice. Now the next one is the green light right here. And I'm going to go to the next output terminal, right? And the next output terminal is exactly Y1, right? So Y1 is the next terminal. I'm going to use that Y1 terminal to connect the second output, which is my green pilot light. Thank you for hanging in there, everybody, and visiting. Hopefully, you guys can build your system. And that's the second output. The third one is going to be the yellow one. And let's do the third one. It's got a large head. I'm going to cut the head a little bit just to make it a little more streamlined. Okay, and this terminal is going to go into the third terminal. Okay, sounds like it's not loose. Let me loose it up a little bit. There we go. It's hard for you guys to see, but hopefully you believe me what I'm doing. And with that, you should be equipped to go and build your system. All right, let's see. Oh, it didn't type. So I missed that. I'm going to loose it up again. Loose this wire. This is the third or Y2 output that we're trying to get in. And see, this box is pretty big compared to the other box. But even with that, sometimes it's challenging to put these wires. I think it's going to go well this time. So, okay, so that is the third output. I have just wire. Okay, third one. And then we have one more. That's the fourth one. That's the red one. Or the blue one, I'm sorry. Blue one is the fourth one, right? Blue one is the fourth one. I'm going to cut this wire a little bit. It's a little bit of too far to extend it. And this is the fourth output. Wow, our time is eating us, but hopefully we'll be able to get this thing done. And this terminal is not fun. It's got a little problem here, but let's see if I can make it happen. So nice, that's in. Let's thread that in. This terminal is a little bit damaged, so hopefully it's going to work. Okay, so that was the last one. So we got all four IOs or four outputs properly connected, right? So it looks like we got our job done. Okay, except for, so we need this wire. You see that? Connected to the negative side. And so we're going to have to bridge a gap in there. So the short path to do this is going to essentially, let me do another. I'm going to create a wire loop here to make it easy on us. So I'm going to create a wire loop with wire nuts. We need to speed up the process a little bit. So what I'm doing now here is I'm taking this wire and I'm going to unite it with this wire that's going to go here, right? Which is going to be united with the incoming wire. Okay, this is I'm looping this and this and this. This is what we're doing. So I'm going to loop it here. Okay, and I think I have some wire nuts. Oh, where are you, wire nuts? So I'm going to use a wire knot for that purpose. Okay, just for the sake of time, this is what I'm doing right here. I'm wire knotting this wire right here, this one and this one. Okay, so wire knot, and then this other end is going to unite with the incoming wire from the power supply. So this is looking pretty nice. So I am going to have to use here a hole that is already in place, and it's going to be the second hole to bring the negative wire. I'm sorry, guys, it's a little bit hard for you to see many of the details that are happening here. Anyhow, this wire, again, is this wire right here. This one, I loop it with this one, and now I'm bringing this wire to the negative terminal of the input of the controller, right? To unite it with the negative that's coming from the source, right? That's what we pretend here. So I have that here, and the negative to the controller is the second terminal right here. Okay. Now I am going to go ahead and put it in here, and I'll show you a creative way to solve a problem that we have here. And so this wire, it's our negative common, right? This is our negative common, this one right here. It's gonna go into the negative terminal. Let me trim it a little bit. It's a little bit too long. Okay, and this is gonna go exactly into the negative terminal of the controller. Okay, so if you can see here, it's tough, I know. Let's see, hopefully we can do a good job here. There's going to be another wire that will unite this negative wire, and you probably are guessing what that wire is. Okay, so that's my negative. I'm going to pull it a little bit inside. Pull it a little bit. Okay, you see that? That loop is this loop right here. This loop. Now, we haven't brought this wire yet, so this wire can go anywhere in here. Okay, that's going to be our negative wire. Okay, and for the sake of time, I am going to use what I already have. Okay, so for power supply for this controller, you could use a regular transformer, AC to DC, usually 100 to 240 AC, and out to 20 to 24 BDC. So this one, or you could use an alternative DC supply, which still needs AC input and provides DC output. So I already have this wire here, and with this wire, I'm messing you up here because the colors here don't match, but we can definitely change this. So let's just change the colors here so that we're not confused with what's happening. So this DC power supply has double terminals, right? It has two positives and two negatives. That's just an extension. and it has line, and it has negative, and it has ground. That's the incoming part, right? And so what we need to do with this supply is uh, we need to bring it inside the box. And so for that, I am going to have to remove my wires. Okay, because I already did some testing on this. And what I'm going to do is I'm going to bring these wires inside. Inside the box. You see that very nicely? Very nice. So we have a pretty tight situation here. So I'm going to cut this wire, and we got plenty of wire here to connect, right? And what you want to do is something very practical here. In case someone pulls this out, what you're going to do is you're going to put some tape around. They actually sell some little plastic rubber pieces for this, but I found that if I just tape around like that, right? I'm taping. If you can see, I'm putting a tape around here. That's going to be enough to hold the wire in place in case somebody pulls that. If you want to go fancy, you can find a rubber retainer that goes in here. But you see that? That's pretty good. Okay. So power here and DC out here. So I'm going to put power into the incoming line. Be careful. This is not connected, right? There's no power in here. You see that? It's disconnected. Don't work with power until you have this connected. Okay, so we're going to go according to this ground, neutral, L. So we're going to go ground here. Let's just loosen this up a little bit. Okay. And so I'm going to go ground. This DC power supply is going to go inside the box. You could put it outside, whatever you want. It doesn't matter. But we got plenty of space here to put it inside. So, 2 hours, baby. This is getting hot here. I am going to turn my AC fan on here to help me cope with the heat. It's hot in Texas. I don't know how it's down in Marcos where you are, but here in Texas it's pretty hot. Okay, so we're connecting this, and let's go ahead and finish this up. Okay, I'm just trimming these wires a little bit too long. And connect. Very cool. So I got power connected. Make sure this connection is turned right. Not too far away, I have a group of engineering students working on a project, and they connected this wire run, and they actually smoked and fried the piece of equipment that we're working with. It was a variable frequency drive that was burned out and completely fried because they misconnected all these wires. So make sure you follow schematics. And so what we have just done here is we have just connected this wire right here, right? These wires are the ones that we just connected, the incoming wires, right? We're gonna do this other wire right here, okay, at this moment. And for that, we're gonna use we're going to use, we only need one negative. So we're going to use one negative, right? That negative or that negative, it doesn't matter which one. So I'm going to use one negative because this negative, it is the wire that is going to feed the whole system to complete the loop or the circuit. Okay, so this is my negative. I also need one positive, right? So this negative is going to be needed. I also need one positive, and yeah, because I didn't cut a long enough wire, I had to cut a longer wire here for my positive. Okay, so this is going to be my positive, right, from the DC supply. There we go, positive. So we got positive and negative, and we're almost done. Almost done. Okay, so this box is inside, and now what we need to do is, here's power, negative and positive. Okay, if we look at our box needs both negative and positive, right? So I'm gonna make it easy on us. I'm gonna join the incoming negative wire to this loop. So this is where we are. I already got this loop from this point to this point, right? I'm gonna join this incoming negative to this loop, right? I'm gonna join it. How I'm gonna do that? I'm gonna remove this this wire knot, and then I'm gonna join this incoming negative to the wire knot. It looks like I need a larger wire knot, so let me get a larger wire knot. Okay, so all right, so I'm joining the negative here. Okay. Woo! I hope this is gonna work. Okay. And then I need this one to join the positive. So I am going to use the wire knot that I just disposed for this purpose. And let's cross fingers, Marcos, that this is gonna work. Thank you for staying there. Okay, so here we go. We got everything connected here, right? We did AC, DC out, negative and positive. This is the last wire we connected going through the switch, right? And so now we shall be ready to test this. Wow. There is our trainer prototyper right there. Almost on time. We got 6 minutes, Marcos. We got 6 minutes to test this out. So anyhow, let me bring power to the system here. Power to the system. Let's see, I hope my wire. All right. Exciting to test our project. Marco, thank you for staying there. Okay, so here we go. Power. Woo, baby. And if we did everything right, this thing should work. We're going to do some voltage testing in here in a moment. Oh boy, that's so beautiful. That is so beautiful. Thank you, Almighty, Creator of inventions. Okay, there you go, Marcos. Okay, so we're testing power. We're gonna go and check out. Okay, so this is going to be 24 right here. Let's see if we get 24. Yeah, that's 24. And our clock has say that we arrive our time. So there is 24. Okay. Now, you see that? So we got our trainer working. There is one little issue here. And the issue we have is there's no program inside the controller yet. And that's the reason why the output lights are not on, right? We have no program on the controller, but ladies and gentlemen, I want to present to you your own do-it-yourself beautiful PLC in a box training and development system by Dr. O. I thank you for coming today. And there's a few little things to tweak here, but for most part, the system is working. There is no program in this controller, and that's the reason why we may not see a lot of action happening here, right? Because there is no program on this controller. And so, but you can see that the inputs are all working, right? They're all working and they're doing their part. What is not holding is the power switch. Power switch. So I'm gonna have to replace the power switch. This might be a bad power switch. You see that it doesn't retain. Supposed to retain, but it doesn't. So I have to hold it in order for the rest of the inputs to work. The outputs are not working because there's no program in it, okay, and the controller. But we accomplished our objective. I'm going to be doing a section on troubleshooting so that when you encounter a problem like the one we had, you will be able to fix it. One more time, thank you so much for your attention. There's the power supply inside, DC, AC to DC. Everything seems to be working magically, except for the power switch, which is not retaining the circuit, right? So I have to hold it. There might be a problem with that. And if I hold it, then it works. So I only need to screw this, okay? So we got a working prototype. And again, because there is no program written, that's the reason why we have no outputs that are going on here. We got only 30 seconds left. I wanted to thank you for staying all the way, Marcos, and whoever else showed up. Thank you so very much for coming together today. 2 hours of free training for those of you guys that are going to further develop your knowledge and skills in the area of controllers, PLC, automation, what have you. Thank you so much. Blessings to you and lots of love with enthusiasm from Dr. O. I'll be seeing you next time, okay? Next time we do another training. Thank you so much. Goodbye. And yes, Marcos, the power supply I'm using is protected. But yeah, you definitely want to use a switch for protecting your power supply.